Hi everyone, bonjour. It's great to be back in Paris. I was actually born here, but I only lived here the first year of my life. And since then, I've been back several times, including 5 times to DJ. These days, I work remotely from Virginia for a small consulting firm based out of San Francisco called Truss. And it's one of the best places where I've worked, and one of the things that drew me were the mission-driven projects that help improve people's lives. So for example, my first project was with the Department of Veterans Affairs, the VA for short. And this was a collaboration between the US Digital Service, NAVA, TISTA, and Truss. Now in the US, there are hundreds of thousands of veterans that suffer from health conditions, and they depend on the VA for financial assistance. They can submit claims to receive benefits, but the problem is it can take years sometimes to process the claims. So this group of wonderful folks modernized legacy systems from the 80s and built open source Rails apps that can make it easier and faster to track and process the claims. And so when I joined the project, I worked on an app called Caseflow, which was almost 3 years old. And I remember on the first day, I was warned to not try running the test suite locally because of how slow it was. And given the age of the project, this wasn't very surprising. Raise your hand if you feel like your test suite is slower than it should be. Right, so if you look around, this is a common problem. And there are many reasons why a test suite can be slow. But an interesting one that I don't think we hear much about is human nature. So to understand why we sometimes behave in ways that don't benefit us in the long term, let's go back in time about 200,000 years, which is roughly the age of the modern human brain. Back then, we were always focused on the present, on surviving. If we were hungry, we saw an animal, we hunted it, and then we were satisfied. So scientists call this type of an environment an immediate return environment because we can see the result of our actions immediately. Today, however, we live in a delayed return environment because the work we put in today can take years to pay off. For example, if you practice deliberately every day, you might go from no coding experience to a senior engineer in a few years. But the problem is our brain has not yet adapted to a delayed return environment, which our society shifted to only about 500 years ago. So compared to the age of the brain, it's very little. So our brain still prefers quick rewards that happen now over potentially larger ones that happen in the future. And this is especially true when we make decisions that have negative consequences that don't happen until far in the future, because our brain is wired to pay attention to immediate threats, but not so much to gradual warning signs. So it explains why some people have bad habits that affect their health, and why many projects end up with technical debt and slow test suites. And so when we don't follow best practices, we might enjoy the immediate reward of high test coverage and shipping quickly, but then when our development slows down later on, we'll feel bad. But with good habits, it's the opposite. The initial work might not be very enjoyable, but the end result feels great. And so because of our bias towards the present, we don't internalize the long-term benefits of speed improvements, whether it's for a test suite or the way we perform various actions on our computer every day. And so we're not sure if it's worth spending the time to optimize a test suite if we're only going to save a few seconds. So how did I know that it was worth it on the Caseflow project? Well, I didn't know for sure, but I tested my theory using the Pareto principle, named after Italian economist Vilfredo Pareto, who was also born in Paris. And the principle is also known as the 80-20 rule, because he observed that 80% of the land in Italy was owned by 20% of the population. And this rule has been applied to other fields as well. So in engineering, you might find that 80% of the bugs come from 20% of the code, or that 80% of the code was written in 20% of the time. So using this rule of thumb, a good first place to look in a Rails app is the Rails helper file. So in our case, 268 lines long, mostly helper methods and methods for seeding the database. So to test the theory that something in the Rails helper was slowing down the tests, I ran a set of unit tests that didn't require loading Rails at all. And they ran in about 17 seconds, which seemed too slow to me. So then I noticed that none of them explicitly required Rails. So I thought, well, maybe we're automatically requiring Rails helper everywhere in our .rspec file. And we were. So then I removed the flag, ran those same tests again, and this time they ran in a fraction of a second, almost 450 times faster. Now, this doesn't necessarily mean that the entire test suite will be 450 times faster, but it's a sign that we're on the right track. So then I looked through the large Rails helper file for any obvious clues, but nothing jumped out. So I thought, well, maybe it's something in the spec support folder which we were automatically requiring. So then I disabled those, then ran those same unit tests, but this time adding the Rails helper flag again, and I saw the same speed improvements. And so then after some more investigation, I narrowed it down to the database cleaner file. Now in the Caseflow app, we use two databases, Postgres for new data and Oracle for legacy data. And it turns out that cleaning Oracle is a lot slower than Postgres by about 5 seconds. And I had a feeling that there were enough tests that didn't use Oracle that it would be worth it to selectively clean the database only when needed. So to do that, I split the database cleaner file into two separate files, one for Postgres only and one for Oracle plus Postgres, and I configured it to only clean the database if the spec was tagged with either Postgres or all DBs. And then we excluded these two new files from being automatically required, and instead we had to manually add the proper require statements in each test and add the tags. So this is an example in a controller spec. So then I had to go every single test and figure out if it uses the DB, which one, and add the require statements and the tags. And as expected, this work was not enjoyable. But I kept the future reward in mind. So once I was done, I tested these changes against a subset of the tests, basically all the tests except for the feature specs, which are slow by nature. And so before the changes, they ran in about 18 minutes. And after the changes, drum roll, 6.5 minutes. Now, I thought this was a big enough time difference that it outweighed the cost of having to do all this manual work. And because we're human and might forget to add the proper require statements and tags, especially when this workflow is still new to us, I added a new rule to the danger gem, which we were already using, which basically would check if a PR made any spec changes, and it would display a warning in GitHub like this. First, it would remind people to try to not use the database at all, if possible, in tests. And if not, then to tag them appropriately. So problem solved, right? Well, not quite. Some tests slipped through the cracks and ended up being merged with DB cleaning issues that resulted in flaky tests that were hard to troubleshoot. And on top of that, I ended up leaving the project for unrelated reasons, but I was keeping up with these suspenseful developments in GitHub. So these changes were merged in late July. I left in mid-August, and then in late October, they had a meeting to discuss these flaky tests and whether or not they should revert the changes. And then in mid-November, they reverted the changes. And so what was interesting to me, but not surprising in hindsight, is that they thought that the changes did not have much of an effect in Circle CI. But in my mind, it was unquestionable that the tests were faster. But I obviously failed to communicate that. I was focusing on the local time savings where the tests were not run in parallel. But in Circle CI, we had parallelism set to 5. And so when they didn't see the huge time difference, they were disappointed. And so this is actually a classic example of a cognitive bias called anchoring, which describes how we're influenced by numerical reference points, even if they're not relevant. This has been demonstrated repeatedly in many different scenarios. So in one example, with some students at MIT, they handed them a sheet of paper with various items on it, like a nice bottle of French wine, and they asked them to write the last 2 digits of their social security number at the top of the page, and then again as a dollar amount next to each item, and then to say yes or no whether they would pay that amount for the item, and then finally how much they would be willing to pay. Well, it turns out that those with the high range of last 2 digits ended up bidding more than 3 times as much as those with a lower range of digits. So similarly, when I kept repeating the number 6.5 minutes, that became the anchor, the reference point. And so essentially, my teammates were asking themselves, how long am I willing to wait for Circle CI to finish? Well, certainly not 17 minutes. But not only that, the 6.5 minutes, if you recall, was only for a portion of the tests. And the 17 minutes displayed by Circle CI is for the entire build process, which involves setting up the environment, downloading custom Docker images. The RSpec portion of that was only about half of that. It wasn't until after I left the project, while working on a blog post about this, that I took the time to measure the difference in Circle CI, and I came up with 39 seconds per build, and multiplied by an average of 50 daily builds at the time, this resulted in 3 work weeks saved per year. Now notice how I use the word saved. It feels natural to talk about time savings, but it turns out it's the wrong word to use in this situation. So to understand why, let's take a look at 2 important concepts from behavioral science, which are the framing effect and loss aversion. They were introduced in the late 70s and early 80s by Amos Tversky and Daniel Kahneman. So the framing effect is a principle that our choices are influenced by the way they're framed through different wordings, for example. And loss aversion says that we experience loss twice as strongly psychologically as an equivalent gain. And marketers take advantage of this when they try to get us to choose something that's not appealing by framing it as a gain. For example, a 5-second ad that you can't skip feels like a loss of 5 seconds. But a 30-second ad that you can skip after 5 seconds feels like a gain of 25 seconds. Conversely, if you want to convince people to do something that benefits them, it's better to focus on the consequences of not taking action as opposed to the benefits of taking action. So in my case, I should have framed it as losing 3 weeks per year instead of saving 3 weeks per year. But given we're engineers, I'm not sure that framing alone would have been convincing enough, because we like data. So to verify whether the changes did make a difference in Circle CI, the Caseflow team measured the build times before and after reverting the changes, and they found that after reverting the changes, the build times increased by 90 seconds, and at the time, the daily builds had also increased to 80, so now the total loss was almost an entire quarter per year. But this still doesn't address the flaky tests. Given the cognitive biases that cause us to make poor decisions, how do we reduce the risk of broken tests or of slow tests in general? So for this, a framework I like is the 4 laws of behavior change, which James Clear wrote about in his excellent book, Atomic Habits. And they're built upon the habit loop that Charles Duhigg wrote about in his book, The Power of Habit. So to reduce the risk of the flaky tests, we can use the 3rd law, make it easy. You want to reduce the friction that prevents people from taking action. And in this case, the friction was having to figure out which database was used by a test and adding the require statements and all that. And so one idea I had was, how about if we check before we run each test whether the database is empty, and if it's not, then we know that a previous test did not clean it. And so I came up with this rspec config block that'll check the state of the database and let you know which tables were not empty, which test failed, making it very easy to catch these early on and making them easy to fix. So I proposed this to the Caseflow team, but I'm not sure if they've tried it yet. Now, another way to ensure success is to prevent bad habits, which is an inversion of the 3rd law. So make it easy becomes make it difficult. And one way to do this is to use what psychologists call a commitment device, basically a system that you set in place in the present to prevent you from pursuing a bad habit in the future. So for example, when Victor Hugo was writing Notre Dame de Paris, he was procrastinating. And his publisher got mad. Oh, Victor, c'est pas sérieux, hein? He's like, you have 5 months to finish the book, otherwise you'll pay us 1,000 francs for each week you're late. And Victor was like, what? I better get to work. So then he bought himself a nice bottle of ink, a gray shawl that covered him from head to toe. Then he locked away his formal clothes so that he wouldn't be tempted to go outside. And that worked. He ended up finishing the book 2 weeks early. Now, another example of a commitment device that you might already be using is GitHub's feature where you can't merge a PR unless certain checks pass, right? So another check you can use to pay attention to those gradual warning signs is to measure the speed of your test suite, so like tests per minute, for example. And measuring things that you care about and making them visible is very important because it removes the uncertainty about the state of your test suite and also provides immediate feedback, which is often missing from a delayed return environment. So for example, you would pick a threshold and make sure that it doesn't drop too low, and if it drops too low, then you'll use the commitment device to prevent the PR from being merged unless you fix this new spec you added, or maybe speed up a previous test, or even delete some tests. I think deleting tests is underrated. Another check you can use is to look at the ratio of your unit tests to acceptance tests, because you don't want to end up with a disproportionate amount of feature tests. And another powerful way to influence behavior is to focus on social norms. And this would fall under the second law, make it attractive, because we have a desire to belong and be respected by our peers. And we tend to follow the crowd for that reason. But also because it makes sense to rely on the experience of others when we're not sure what to do. And we do this often before buying products or choosing Ruby gems. An example of using social norms comes from a study in the UK where they were trying to get more people to pay tax on time. And they tested a whole bunch of different messages, and the one that made the most difference was a combination of two sentences, one that focused on what people in your kind of surrounding immediate area, how they behave, and then another sentence that made it personal. And in this case, your local area could be replaced by the specific name of the city. So using all of these examples we've seen so far, let's see how we can apply all 4 laws of behavior change at the same time. So for the first one, make it obvious, one idea is to display a dashboard that's always visible while you work and that shows your progress and the metrics you care about. And so an example of this is how the Prius was able to change driving behavior by displaying a dashboard that shows how, in real time, how the driver's actions affect their gas mileage. And then to this, you can also add the second and fourth laws to make it attractive and make it satisfying. So when you're doing well, it would show statements of praise and encouragement that show you're following the same best practices as other successful projects, and that reinforce the value of your effort. And so this would be the reward part of the habit loop, and which is what makes you want to repeat this behavior. And then when you're falling behind, you'll use the inverse of the second and fourth laws, make it unattractive and unsatisfying. It will remind you that you're in the minority, and most projects similar to yours have faster test suites, and this is how much it is costing you. And then you can also add the inverse of the third law by using the commitment device to prevent you from merging the PR. But then because we want to get back on track, we can use the regular version of the third law, make it easy by giving you examples of how other projects sped up their test suites, or even maybe building tools that can automatically detect and fix common problems, like Robocop's autocorrect feature. And so, this is a small sample of the valuable insights that behavioral science can provide. I encourage you to read more about this and see how you can apply it to your work and personal life. As Daniel Kahneman says, the most effective check against cognitive biases comes from the outside, because others can perceive our errors more easily than we can. So the more of us are familiar with them, the more we can look out for each other. Thank you.